Imagine waking up to see the sky filled with the golden glow of Saturn, larger than the moon has ever appeared. As Earth drifts closer, the beautiful rings that once looked peaceful begin to reveal billions of fast-moving chunks of ice and rock. What looks like a cosmic masterpiece from far away could become a global catastrophe up close. But how bad would it really be if Earth entered Saturn's rings? To understand what would happen, let's dive deep into Saturn and its rings. Saturn's ring system is the most extensive and complex planetary disk structure in our solar system. It is made of trillions of individual particles, ranging from tiny sub-micrometer dust grains to boulders several meters wide. These rings form an extremely thin, differentially rotating disk composed primarily of about 90 to 95% pure water ice.
Saturn's rings are vast and constantly active. Typical ring particles orbit at incredible speeds, tens of kilometers per second, at distances of roughly 70,000 to 140,000 kilometers from Saturn. Their sizes range from microscopic grains to objects as large as small houses. Despite their enormous width, the rings are surprisingly thin, usually only around 10 meters thick, though rare vertical mountains up to 2 kilometers high can appear near gravitational resonances. Inside the rings, particles collide frequently and are continuously influenced by the gravity of Saturn's moons. Particles in the inner rings move the fastest, traveling around 16 to 24 kilometers per second. For example, particles in the inner C ring orbit at around 23.6 kilometers per second, while particles in the outer A ring near 140,300 kilometers move at about 16.3 kilometers per second. B ring particles, located between 92,000 and 117,000 kilometers, orbit at around 18 to 20 kilometers per second. In the outer F and G rings, particles move slower, around 13 to 15 kilometers per second, because they are farther from Saturn. Saturn's surface gravity, at around 10.6 meters per second squared, is only slightly stronger than Earth's 9.8 meters per second squared. But Saturn is vastly larger and far more powerful. Its escape velocity is about 35.5 kilometers per second, compared with Earth's 11.2 kilometers per second. Saturn's gravitational sphere of influence is enormous compared to Earth's.
Now imagine Earth entering Saturn's rings at speeds of 16 to 20 kilometers per second. Our planet would immediately be bombarded by ring particles. Based on estimates from the Cassini-Huygens mission, Earth sweeping through the rings could encounter more than 10 to the 16th kilograms of material. Each single kilogram striking at around 17 kilometers per second would carry roughly 1.4 times 10 to the 8th joules of energy. In total, the energy released could reach 10 to the 24th to 10 to the 25th joules, vastly greater than any disaster in human history and equivalent to millions or even billions of nuclear explosions. Even a single meter-sized block, weighing around 1 million kilograms, could release around 10 to the 16th joules on impact. The result would be catastrophic. Massive craters would tear across the planet, while the atmosphere would rapidly superheat. Forests, cities, and surface materials across the world could ignite in global firestorms. A blast wave would race around the planet, flattening structures across entire continents. Crustal stress could trigger earthquakes far beyond anything ever recorded. If impact struck the oceans, walls of water thousands of meters high could rise near impact zones, creating destructive global tsunamis. Dust, ice, and debris would fill the atmosphere, blocking sunlight for months or even years, causing a devastating impact winter. At the same time, Saturn's tidal forces would place Earth under extreme stress. If Earth moved inside Saturn's Roche limit, around 117,000 kilometers from Saturn's center, our planet could begin to break apart under gravitational forces. Even outside that limit, Saturn's tidal pull across Earth's diameter would be strong enough to create severe internal stress, crust movement, and massive geological instability. Earth's own gravity would be far too weak to protect it. While a few tiny particles might be captured or deflected, most ring debris would strike Earth at enormous speeds. There would be no stable way for Earth to gather ring materials safely under such violent conditions. Eventually, Earth would be almost completely devastated. Life as we know it would nearly end due to the unimaginable energy release, global earthquakes, superstorms, freezing darkness, and planetary destruction. Even our moon would be affected. In the end, nearly everything connected to Earth's world would face collapse.